Thank you, Mr. Chairman. Ladies and gentlemen, good afternoon. See, the theme of this international conference is soil mechanics and geotechnical engineering in highlights and underground construction, named after Ther-Mартиросяна. So I take the topic of the underground space. So the title of my presentation today, case study, okay, development of underground tunnel construction technology, which were implemented in Incheon and Korea. So it takes about 10 hours traveling from the Songdo, Incheon, where our school located, to Moscow. So it's a panoramic view, look down, all the way from the Central Asia to the west part of the Asia and the European and the Moscow. So I'll talk about the background of this research work and concept of the tunnel methodology by the Natum method and pre-supported tunnel method, fundamental theory, and also case history. And number 4, I'll talk about metro construction work by the TRCM and theory and the case history. So megacity is about modern population 10 million people. Then we called megacity. So Professor Askar Jusbekov is the chairman of the TC Technical Committee 305 megacity and the new capital under the umbrella of the ISSMGE. So future city need more and larger underground space. So I know Russia is a very big country, so you don't need, really deep excavation, except, those highlights building and so on. The top left-hand side is the station, express station in the part of the Singapore, between the Malaysia and Singapore. That's underground space, well developed. That's under construction. Right-hand side, at the top, is the Singapore, okay? They want to develop 6 different layers of the underground space. And there's parking lot, and also another garage, and also the shopping center, and the departmental store, and so on. I found out that the final, the 6 layers in the bottom, they want to have an ammunition storage tunnel, that something, they're very risky, but they want to put it. And the left-hand side, in the very congested area in the Seoul, we want to develop, above ground. Now we have a highway. We want to put the highway underground. And also we are under construction of the high-speed railway. So from the satellite city to coming to the downtown. So GTX. Normally the depth of the tunnel, more than 30 meters. So normally 40 and 50 meters, because up to below 30 meters, the properties belongs to the government, private owner. So above ground properties that can has obtained their right about the depth of 30 meters. So we want to have avoid the litigation problem. So more than depth 30 meters. So 40 meters, 50. So normally we go to 50 meters. So there is no problem, so digging the tunnel. And the right-hand side is the underground tunnel, the path through the sea, about 5.6 kilometers long. So we had a lot of consultancy work was this tunneling problem in Incheon. So for the secondary perimeter highway. So Teresage, lock road with supported system, 1946, provided this formula by the empirically. Okay, so depends on the losing depths of the rock, HP. So with the different rock condition, good rock condition is on the top, and the very bad rock condition, and the bottom. And the height, HP, is different, and depends on the rock quality. We have different types of the rock supporting system, right-hand side. This is a very fundamental I use, for this, for my class. And rock condition depend on the, IQD, RMR, right? Q system, don't need the. So it depends on the rock condition and also width of tunnel. We have different types of the supporting system. Very poor rock, and we can have still leave support, but have a very narrow space of the tunnel and the good rock quality. You don't need any support, but maybe only rock bolt may be required. So let us talk about the Natum method, new Austrian tunneling method. So this is conventionally we excavate out, and the soil is losing, losing state. We supported, the system later on. So already loses, so it's a problem of the stability. But here we can excavate section by section. After you excavate number one, and then you put in the shotcrete, okay? Maybe 10 or 20 centimeter, thick of the shotcrete, cement mortar mixed with the steel fiber or polymer fiber, and you shoot it, and we're coating it, covered it, so that temporarily you support it, and then soil layering or rock bolted, okay, and tight it. That's the methodology of Natum. So by this methodology, you can recreate the equilibrium of the state, okay, and the elastic plastic state, and then if the rock condition is good, you can excavate both, number two section. After then, you reinforce it, and another layer, number three and number four. And sometimes, if you have a soil is very bad, like a big, very weak soil, you can put in the steel pipe grouting wall. Okay, so we say pipe roof method. Okay, sometimes this pipe roof method all around from the top to the bottom. So very expensive. We do use that one in the Incheon, the second, the metro system, and also bottom. Bottom maybe the soil condition, rock condition maybe not good enough. Then that's swelling. So you need the inbolt, reinforcing method, for this case. Okay, so all the Natum is a most cheaper method. So if there is not many residential, area, the housing around that, not downtown, then you blasting it. That's a Natum method. But there has a lot of cracking problem if we do it in the downtown. There are a lot of litigation problem that occurred. So we try to not to use the Natum nowadays in downtown area. Okay, so we adopted one method, pre-supported method. This method we developed it. Mr. So, one company in South Korea. So what they do, first they put in the a pilot tunnel. The width of this tunnel about 8 to 10 meters. Okay, a machine and the mobilizing arm is maybe 3 meters, and soil layering maybe 8 to 10 meters. Okay, so once you completed the pilot tunnel, then machine you drill the hole, and we pressurize grouting. Number 3 photograph, the right hand side on the top, there's only red color, there's a pressure grouting, there's a permanent, the fixing of the tunnel, but not grouting on white one, that we're blasting in the conventional way, we break it. So that makes the left hand side, this one, okay? So you can have a very big, wide open area, and you pressure grouting it. And then bottom you cut it, and you supporting system, the pre-supported tunneling method. So that methodology can use in downtown area. Somewhere you have a very congested, on the ground surface near to metro area, metro station area. Then you cannot excavate, some traffic volume, and large traffic volume. Then you grouting it from the top, and then very shallow depths of the top soil. Then you excavate out, okay? And the down below, instead of a twin tunnel has a lot of problem. in between the twin tunnel, see that here, maybe a lot of water will accumulate this area, okay? So that create a problem and more costly. So we want to do, instead of a twin tunnel, we want to make one big tunnel, okay? By using this method, pre-supposed tunneling method. So this is one case history. So this tunnel, about the length about 321 meters. One is the right-hand side, there's an industrial complex. But the left-hand side, there's a major highway. So if there's a big mountain, so it takes about 40 minutes, detour to reach to the industrial complex. So we want to make a tunnel, okay? That you can access, 5 or 10 minutes to the complex. So originally designed by the Natum method, okay? Because both sides, left hand, right hand side, there's a weak zone, okay? So, and in the middle part, only in the hard rock. So that, but this company, they suggested, okay, we want to use, pre-supported tunnel method. So in the weak rock, both sides, we use external, and from outside, external the soil layering and the grouting it. So solidify it. And inside in the central part, from the internal reinforcing it. Okay, this we implemented. So this is a left-hand side. This is internal, the grouting it, soil layering and the pressure grouting it. Okay, and the right-hand side is from the external outside. You pre-boring and then injected the grout. Okay, so that successfully implemented. Now we are doing the pilot tunnels, okay, on the construction, and the right hand side also the excavate and the pilot tunnel, and the pilot tunnel is completed, and then we blasting it, So we know the methodology how to cut out, and the on-ground section just drop it, very quickly. So that right hand side is completed. We have done 6 projects so far, and by utilizing this. So my friend, he said, Professor Shin, you go to Moscow, you discuss with some company people on Scala in Russia, so we can work together, So I think this is one, Well, particularly some ammunition storage tunnel or some tunnel, So this is inexpensive in the bad soil in the bedrock area. And the other one is, which I consulted, I think some of our guests visited Incheon. I take them to this site. Tunneling method worked by the TRCM, tubular loop construction method. This is a view of the metro line 2, and about this area. This area is problem. This is a main metro line 1 from Seoul to Incheon. So width of this line is about 60 meters. So we enter pass through the tunnel, underneath of this, the metro line number 1 station. So below that bottom, this is a very wide, So far we did 30 meters drilling the tunnel by using this method. But 60 meters, they're very difficult, Maybe metro above, maybe falling down, big disaster, maybe big sinkhole happening, So Professor Shin, is that possible, So we did the methodology, grouting it, so solidify, holding the groundwater, and then we have a numerical simulation, and we tunneling it, we found out, So they gave me big consultancy money for this project, and then, so this is a line we have about the metro line. We have.
So you have 3 minutes, Professor. 3 minutes.
2 major lines, and the several, the connection from between the Seoul and the Incheon, and this is a method, okay. First, we have a gallery pipe, but 2.2 meters, 3, and then you connection and excavate out down below. This we have the marine clay, soft marine clay in the left hand side, this part, okay, and thickness only topsoil 3.3 meters, very thin, so very difficult to do it. So this is sequence 1, 2, 3, 4. Okay, so you look at it. This one, gallery tunnel. You press it. Hydraulic jack. Press it, excavate out. Meanwhile, when you progress the work, you grouting it top part, and then you push it, excavate out, and push it. And then once you complete it and the transverse direction, you put in the tube and reinforce it. And finally, right hand side is a completed one. So, and we did a field monitoring work for the inclinometer, groundwater table, settlement on the ballast, and groundwater plate, and the settlement plate, and so on. Okay, all. And we layout of the ground monitoring work, all this. And now see, this is a very, clever, to binding together. Because sometimes this locally may be sinking, some ballast or something. So we binding together. This is an inclinometer. And there's a settlement, up and down, maybe 0.3 millimeter, within that range. And inclinometer is not very much. But the problem is here, the groundwater table that we excavate out in the soft clay for 26 meters deep, that creates the groundwater down, that creates maybe some problem. But all the settlement levels and everything is under the limit. So we calculated control limit and the measured value, and it's not much, all the below the measured value, the standard, But the groundwater table is some problem, but we have solved the problem. So we successfully implemented 3 different methods, but natrium is maybe in downtown area is not to use, But mountain area we use, but nowadays we do use a lot of shield. Okay, they're costly, but we use a lot of shield method in the high speed the railway with between connected satellite city to downtown Seoul. And pre-supported method also is very good, feasible, economical method to use it. And TRCM is time consuming, but there's a very soft soil, Then we can do, one by one, maybe takes 6 or 7 years, to be completed. But, this is a good solution, to eliminate all any, environmental problem and the litigation problem. Thank you very much.